Made in Germany clamp. Yes. Let's make the eccentric. My little copper piece in here. Ah, that's better. Okay, that will do. We'll see. Now, problem. I didn't think of that. So I have to cut out a little bit more of my cylinder here. It's now cut off, which means that I can assemble my eccentric thing here without using big hammers or crowbars. Don't mind the wiggle, it's the table that's not, that's all. Right, I think this is the right moment to make a groove in the piston to receive the connecting rod. This groove is now 10 millimeters deep, and I made it with a 4 millimeter 4-flute cutter. I don't know if this information is important for you, but I never tried this. Of course, this is a piece of aluminium, and I always heard that you better use 2-flute cutters in aluminium. But I took light cuts, and I think this 4-flute is more stable in the groove than the 2-flute. And I think it worked like a charm. Of course, I used the coolant to wash away the chips, so now there's chips here all over the place. But it worked. I just found this beautiful little piece of round here, which used to be a part of a printer. It's 6 millimeter and nice and precise. I think it's ground or something, or whatever. It looks like beautiful piece. And if I drill a hole 6 millimeter just with a drill in my connecting rod, it gives a very nice fit. So I think I'm gonna risk to drill 6 millimeter in my rod, in the correct side of course, and in the piston, and then put a little piece of this thing in here as a connecting pin. Yes. Okay, let's make a crank pin eccentric thing here. That could work. Something like this, for example. All that's left to do now is drill holes here in the main body. I think I will put them here on the back side. here so the pipes can come out here and stay horizontal to go over here, and the other one over here. So drill holes make a little bit hardware to fit hoses, and cut out the notches here in the crankshaft. Let's take it apart again. Before I do some irreversible damage to my beautiful crafted parts here, let's go to the blackboard and study a little bit of theory. If of course the part is cut into in half this way, and here will come the valve that goes to the cylinder. Rustinox is in the way. Cut in half. I hope this is more or less clear. If we make a notch in the shaft that is not really, let's do it again. If I cut out a notch right here, it means that through this hole, let's open this port up, for the moment air can come in and go out to the cylinder. Let's make the same here. Air comes in and in the other port out to the cylinder. This is the middle of one stroke, which means if, for example, my engine is running to the right, this point on the shaft will be the opening point right here, and the other point here will be the closing point. On the other side of the shaft there's also a notch that starts here like this, and this port is just open to the air. Rotate 180, the air can come back from the cylinder through this notch and escape in the air. Right. The distance between this point and this point, I have no idea. The thickness left here between the notch on the top side and the notch on the bottom side must be at least the width of one port opening. Yeah? If it's smaller, the air will come in and out at the same time, so I need larger. To make the connections here on top of my beautiful little part here, I will use some 8mm threaded rod, because the fit with the plastic pipe thing here is not bad at all. That's the only reason. And I determined that, let's make it here, I have to cut a depth of 2.5 millimeter here. Now, I determined this with the trial and error method, with these things and then this thing, and I think it's the best method you can think of, because it's very precise if you're lucky. I drilled and tapped one hole in here. I tapped not the all way through, and I cut off two little studs, metric 8, gave it 2 contra nuts and a touch of Teflon tape. Which means if I put this little stud in here, like this, now in theory it will not pass the hole. I think that's a success. Yeah, that looks good. So if now I take off these two nuts here, of course it's way too long, I will cut it off, but first let's hollow it out. And now it will be easier to determine where to drill the other two holes. Because if they're too close to each other, I won't be able to put these nuts in place. These holes are not centered in the studs, which means the studs are a bit in an angle. I can't figure out why. I think all the parts are finished and I'm ready to do the final assembly and maybe the first test run. On this side you can see the two vent holes, this one to the cylinder, here comes air in, and then the other one is open to the air. The crankshaft without crank for the moment, and you can clearly see the two cutouts. Right, let's assemble. I install copper rings that will serve a little bit as a bearing material. Now for the timing, I will put some air in the system. You can see the piston moving. I want this engine to run that way. There's no particular reason, but that way. Which means when the piston is completely up and it wants to start to go down, like this position, that's where it needs air to push. So let's put the air in place that I've got here. Maybe give it some pressure. I'll be back. Right. The pressure is set at 2 bar. It's about 30 psi. And if I open the valve here, okay, that seems to work. Of course, my little valve is leaking a bit. Let's put this little hose here in place. Test. That looks good. The valve is closing when the piston is almost completely down. Opening a bit too early. There's a little bit of bend here, but we'll see if it works. I promise you I never tested this thing before, so you will be witness same time as I do. There it goes. There's some terrible knocking here. I don't really know where it comes from. After a little bit looking around, I found out that the piston is binding a bit here at the end of the stroke. And that's why it's making this rattling noise. So I cleaned it up a bit. I still have to clean it better, but here it goes. Is that cool or what? Conclusion. Making engines is fun. That's all. And now something completely different. For next week's video I would like to do some shaper special, some kind of Q&A. Which means if you have questions related to shapers, of course, don't be afraid to ask, put it in the comments or send me an email. You can send pictures with specific, complicated words, specific questions about shapers. Now, of course, I'm not at all pretending I am specialist, but these few little flight hours I have on shapers I would like to share with you, because I see in the comments and in videos and also in my emails that more and more people are willing to learn shapers. more people are interested in shapers and start restoring old shapers. So if you think I can be for any help, don't hesitate, put it in the comments, and for next week it will be the shaper Q&A.